Hello everyone, welcome to episode 68 of Reconstructing Cave Story. Today we're going to be implementing some 2D data structures. These have been a long time coming. I really should have done this to begin with, but I'm doing it now, and it's alright that I waited because we got the nice kinematics abstraction, which I don't know if I would have come up with had I not done it this way. But the problem we're facing is position, velocity, kinematics all come in XY pairs. You have points on the screen that are XY pairs. You have velocity that's XY, kinematics XY. We need to pair them together and be able to work with them in pairs. So we're going to have a templatized vector 2D, and this is going to represent our position and our velocity. And we'll create some mathematical operators for it. We'll overload operator plus, minus, times, and divide for plus and minus for vector 2Ds, and times and divide for vector 2Ds and floats. So multiply a vector times a float, or divide by a float. And then we'll also want to be able to convert between different vector 2D types using our tile to game type conversions. This is going to involve function pointers. You don't have to do it this way, but I just thought this would be a neat thing to show you guys, and it's not too unfamiliar. It'll just be a little bit interesting because you'll be passing a function as a parameter to another function, and for some people that's like really straightforward, but for other people it's very confusing. So don't feel too bad if it's confusing. Just it's sort of functional programming, higher order function kind of thing, but it's not a higher order function. So don't quote me on that one. But then we'll also want a kinematics 2D, which is not a vector 2D, and that's because you don't add and subtract kinematics to each other. But we still have an XY pair, and I'd like to get rid of that. So a couple of benefits of that is we'll have a position and a velocity getter for our kinematics 2D, and it'll be easy to get that information out. And you might be wondering, what about power Doritos? Yeah, we're getting to that. I want to clean up map collidable a bit because it's pretty messy, and this is one of the few cleanups I want to do before we get there. But it'll all be okay. We'll get there, don't worry. I should also mention in graphics, I kind of cheated. I don't want to use boost file system because it's not just a header boost library, so that means linking. And on Linux, that's super easy, but on Windows, it's a pain in the butt. So I'm not going to do it. I'm not going to bother with it because we're just using it for this error checking. And I don't even know if I did this error check in video. I might have just thrown this in here as a bonus to the people who are subscribed to my Reddit. But anyway, yeah, let's get started. So let's start by adding a new item. We're going to start with the vector 2D. So I'll call it vector2d.h. By the way, back in Windows, I tried to do it in Linux and it just didn't work. The audio was choppy and it was cutting out parts of the video, and I just like, screw it, I'm going back to Windows. So I've had it with trying to record on Linux. But yeah, that's why I'm back here again. So this will be struct vector 2D, and it's going to be a template. So let's call it template type name T. We could make this any type name. We could call it number, but that's kind of big. N kind of indicates that it's an integer. I like T. It's a number type. It's going to be like a float or an int or an unsigned int. We don't really know, but yeah. So let's start. It's going to have an X and a Y. Let's make a constructor for it. So this first constructor is going to take in, we'll just take in a T, X, and a T, Y, and assign them. So X, X, and Y gets Y. Let's, also give ourselves a default constructor still, because it'd be nice if we can say, hey, I just want a zero vector. So that's an easy way of doing that. And then one more I want to do is just have it take in a single value and assign X to be that value and Y to be that value. So now that we have our constructors, we can implement our operators overloads. So these are all going to return vector 2Ds. They're all going to be const methods. let's start with plus. That seems like a very elementary place to start. Operator plus, and it's going to take in another vector 2D. And we'll call this other. Or how about just O? These are really simple. And we'll just return a vector 2D. Ooh, also make this const. And we'll just return a vector 2D of x plus O dot x and y plus O dot y. Very simple, very, very simple. So let's do the same kind of thing with operator multiply. That seems like a good place to go to. And no, I'm not going to take in float. How about a t for m multiply? We'll just call it t. And this is just going to be x times t and y times t. And the reason I'm doing a t is just in case like we have an unsigned int, I only want to be able to multiply times unsigned int. If you want to do it a different way, you have to do it without using these operator times operator plus, because these members are public, so you can do that. Next, let's do divide. And we can actually do divide in terms of operator times. And actually, I'll talk about more about operator times before I do divide. So let's do that first. So I just want to mention that right now, this is a vector 2D times a t. So we can have a vector times some float or whatever. That's what this function will take care of. But if we want to have a float times a vector, this function will not take care of that, because this function implicitly takes in this vector as a first parameter. So what this is really doing is it's translating this, first of all, to operator times vector dot operator times float. So these two statements are actually equivalent. But this means that we don't have float times vector implemented yet. So we can do that by creating it outside here. We'll need to rename our template. So type name t, because we're no longer in the struct, but we can inline, because we're in a header file, we have to inline it. And also it's a template, so we have to be in the header file. Inline, it's going to return a vector 2D. It'll be operator times, and it's going to take a float first this time, or not a float, but a t first this time. We'll call it t, and a const vector 2D as the second parameter, v. And this will just return v times t. So we just switch the order again and use this operator times. So now let's do operator divide. And we actually will only want one version of this. We don't want to be able to do t divided by a vector, because that doesn't make any sense. We just want to do a vector divided by t. So this we could just do like this. But I'd rather just implement it in terms of operator times. So to really prove that operator times is just another function, I'm going to write it out as a function call. And so this will call operator times, and we just really want to do 1 divided by t. And this should make sense, because we want to when you're dividing by a number, it's really the same as multiplying times 1 over that number. We'll want to be careful when we do this with tile 2Ds, but we probably won't want to be dividing much with that. So that's that. And then finally, let's implement operator minus. This is also going to be in terms of operator multiply as well as operator plus. So let's grab that parameter. So how are we going to do this? Well, we're going to actually add the negative of this O. So we'll add to this O times -1. And that should give us our operators. And I think that's all of them. So now let's open up units.h and give ourselves some more type defs. And then we'll also be able to see if control comma, for those of you actually using Windows, that opens up an automatic finder. It's pretty cool, actually. I'm impressed, Visual Studio. I am impressed. So let's include in our units.h a vector 2D and compile this and see if it runs. Looks like vector 2D needs an argument list, so I'm guessing that is because right here I forgot to add arguments. So when we're specifying our template, we need to say that our vector 2D is templatized by this template t. Otherwise it's just it gets confused because it doesn't know what type to templatize it by. So like this could be a float for all it knows. Doesn't have to be the t. Doesn't have to be the t that we have specified up here. Okay, so let's try building again. And I think that might have been the only error. Yeah, it's units.h, so it has to recompile so much. So much. That's fine. I've seen that one before. Okay. Yeah, I'm pretty much happy with that. Let's go ahead and make some type defs. I'm going to make this outside of the units namespace because I feel like I'm not worried about these having conflicts. With a name like game, you're going to have conflicts, but with a name like position 2D, you're not going to have conflicts. So that's the first one actually, is position 2D. And this is going to be a vector 2D, and it's going to be of type units of game. So now you can kind of see how this is looking. We're also going to need one for dimensions like width and height. And let's do one for velocity. So this will be units of velocity, even though that's really just floats under the hood. That'll be a velocity 2D. And then one more finally for our tile, which will be the only one that it's actually a different type. And so thus justifying our need to templatize this vector instead of just doing a vector of floats. So yeah, the next thing I want to work on is this conversion function, and it's going to involve function pointers, but function pointers really are not so bad. Let's take a look at what this is going to look like. So we want to convert from, say, a tile 2D. We want to be able to convert from a tile 2D to a position 2D, and I'd like to use our tile to game function in order to. I'd like to be based on this tile to game function. So if we ever change it, we only need to change this one function. And to do that, I'm going to first of all write out what we're going to get. We're going to be returning a vector of a different type, so we're actually going to need to templatize this method on an already templatized class. So don't get too confused. This is a different, you can think of this as tile for now. Like let's say we have a vector 2D of type game, and we want to convert it to tile. So that's what this is like. So template, type name, tile. So I'm actually going to call this U, but I'll go ahead and do that for now because it could be anything. It could be we're converting from game to tile or tile to game or something else. So we could even have pixel, pixel vector 2D, but I'm not going to get there yet. So we'll call this convert, and this is going to take in a function pointer, and I'll leave that to be defined in a second. So let's call it conversion func. And this conversion func, and this doesn't have a type with it, so don't worry about it. This is not real syntax yet. But the way I want to use it is I want to return a vector 2D of type U, and it's going to call conversion func on X, and it's also going to call conversion func on Y. And so this is a function pointer right here. We want this to be a function pointer. And the syntax for this function pointer is actually to basically say, first of all, what it returns. So if you think about it, we want it to, it's going to take in an X, and that X is of type T. So first of all, we can say what it takes in. So it takes in a T. And we see that it also is going to return a U because it needs to fill in this vector 2D that's templatized by type U. So we can say that it returns U. And we're like halfway there to actually having our function pointer. The only thing we need to do is say this is a pointer and this in parentheses is the name of it. So that right there is a function pointer. See, it's not so scary. You just have, it basically goes, you start out with the return type, then you have this funny opening pointer, opening parentheses pointer, and then variable name, or function pointer name, and then closing parentheses, and then the parameter list. So this could go on forever if you wanted it to, but really we want a conversion function that takes a t and returns a u in this case. So the way you use the function pointer is just like a normal function call, so it's really not, it's not too scary. And if you actually want to use it, let's say you have a position 2D position right here, position 2D position, and you want to be able to convert it to a tile 2D. So you could say tile 2D is equal to, and this is pseudocode, position dot convert, and you want to give it the units game to tile, and that is a conversion function that will take a game unit and convert it to a tile unit. So that's a cool way of using these functions that we've already made in order to get a different type of vector. So let's build and make sure that I typed everything out correctly. And yeah, function pointers can be really confusing, but they're just pointers, you know. So they can be treated just like any other object. So you can do some functional type programming in C and C++. I tend to not think it's very fun to do most of the time, but this one was very light and simple. Usually you don't have to, usually it involves some funky syntax, and especially with member functions, that member function pointers are just horrifying, so I just won't ever use that. So yeah, that's that. So I'm actually going to finish up the episode by going into kinematics, and the next episode we'll do a pretty serious amount of refactoring, but I really don't want to do all the refactoring in one episode, or I don't even know if we really need to change all of the code we've written, but I would like to change some of the more used parts of the code we've written and some of the more core parts, especially map collidable. So in the next episode, we'll work on some refactors, but this episode is just about building the vector and the kinematics 2D. So let's actually open up kinematics.h. So kinematics 2D is, I'm just going to define it below kinematics. It's not going to be vector 2D again because we don't really want that add, subtract, multiply functionality. That it just doesn't make sense. So we're going to have two kinematics instead, x and y, and we will return a position 2D for position const, and this will just return a position 2D constructed from x.position and y.position. And the same thing except with velocity 2D. And velocity. And so yeah, that concludes this episode. Yeah, so I just want to say, I know I've been gone for a few months, but I fully plan on continuing this on for, I don't know, maybe another year or so. Who knows? But I pretty much have no plans of giving up on this. So if you guys were worried about that, no need. And if you weren't worried about it, okay, that's fine too. But yeah, I just want to say thanks for watching. Thanks for sticking with me, and happy developing.